Hey Devin, what you doing?
I'm grounding the electricity. I have a bunch of electricity running through me right now.
Dude, that is so cool. Isn't that like dangerous though or something?
Actually, as long as I'm completing the circuit, I'm all right.
Dude, that is incredible. By the way, have you met my friend?
Oh no, I haven't. Pleasure to... Hey Spaceheads, did you know that static electricity is caused by an electrical imbalance? And in order to balance it out, electrons will move from one negatively charged space to a positively charged space. It's a little complicated, which is why I want to show you in the headspace. Come on. Let's get familiar with what electricity is in the first place. So we've talked about atoms a little bit on this show, but if you'd like more detail, go check out our episode on atmosphere and gases. You see, atoms have these things that orbit them called electrons, and those electrons love to move around from atom to atom. And when they do, they create an electric current. But not all electrons move freely. There's a little thing called valence electrons. These are the electrons that exist on the highest outer shell. Now there's a limit to how many electrons these guys can have. The max is usually 8, and a good conductor has about 3 or less in that outer shell. So hydrogen with only 1 electron should be a great conductor. Not necessarily. A little refresher about gases is that the atoms have a decent amount of distance between them. And hydrogen is a natural gas, which makes it hard for electricity to move from atom to atom. This is why most conductors are metals. Density is a huge factor in how electricity travels. A dense atom is a great candidate for conductivity. But that's just the basics. There's so much more to learn. Let's hear what the campers have to say. Come on.
In 1884, the first electric car was made.
Never put metal near an electrical outlet. You'll die. Pretty sure that the Tesla coil generates the most amount of electricity.
When you have a balloon and you rub it on your t-shirt and you put it to your head, the static electricity makes your hair go up.
Did you know the Greeks discovered static electricity in 600 BC?
Most high-speed trains use magnets to diminish friction, therefore making them go faster.
Did you know that if you cut a magnet in half, it just creates a new magnet with the same poles?
A fun fact about magnets is that some animals can feel magnetic forces.
Did you know that the lightning that you see actually is going from the ground up, not from the sky down? It's really cool.
Did you know compasses rely on magnetism?
Did you know the electrons of magnets spin in the same direction?
Go, 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 go.
The Earth is a giant magnet.
I'm Jake. I like a little bit of physics. I like a little bit of razzle-dazzle.
That's the most dazzled-razzle I've ever seen.
They're going to take enormous amounts of just electric charge. They're going to deposit them on that toroid shape or that donut metal on top, and it will have a fairly relatively high voltage and electric current output.
You guys ever done parkour?
The hair-raising demo. So, we take our Van de Graaff generator, which deposits large amounts of negative charge on top of this giant sphere. We have the participant hold their hand there. That electric charge is going to be distributed throughout their body, and it will start to go into their legs, into their arms, up into their head, and then it even starts to go into the hair itself. Electrons is going to be the big charge carrier that is carrying this charge onto your body. And so there's going to be negatively charged particles all over your hair. Since they are all negatively charged, they have a like charge, and as they say, likes repel. So all of those electrons want to spread out as far away from each other as possible, but there's still the constraint that they have to be on the hair. So the hair will try to make as big of a spherical shape as it can. That will optimize the distance that the electrons can get away from each other. So that kind of affects the experiment. So I'll take this out.
Tongs look like they're kind of breaking. Yeah, like the
They sure are.
Whoa.
So, you may take a picture. Due to the complete lack of electrical resistance.
How cold is it?
It's very cold, my fingers hurt. We get
Magnetic levitation.
magnetic levitation.
Oh wait, can you?
In fact, the magnetic field is so strong we can even levitate it up. A special type of metal that we've made in a laboratory that has 0 electrical resistance. The electrons can move through there as if there was no material there to stop it with electrical resistance. So our superconductor can achieve this. However, can only achieve 0 electrical resistance at extremely low temperatures.
Now, we've learned a lot this summer, and there's one person I want to thank for that. To Diana Huff for taking a chance on this silly little show, and for letting me try new things. No joke this time. I just wanted to say, hope you guys had a great summer, and until next time.
Wait, was it you that tied the snares?
This program was made possible by our various camp programs and by donations from people like you. Thank you.